block is pushed against the spring with the spring constant 10 kilonewton per meter located on the left side, and compresses the spring to a distance of 5.4 centimeter from its equilibrium position. The block starts at rest and is accelerated by the compressed spring, of course, and it slides across a frictionless track, except through a small rough area on the track as shown. So this is the rough area where we have the friction. It leaves the track horizontally and flies in the air an acceleration and strikes and subsequently strikes the ground. So what is the speed of the V just when it leaves the track? Okay. So the classic question of conservation of energy. Whatever energy it had over here, we can use the work energy theorem. Work energy theorem. Let's consider the compressed point as point A and this as point B. So we know that the energy at A after compressing the spring will be equal to, plus the work done by the friction should be equal to the energy at B, right? Energy at B. All right, okay. So, what is what do you call it as? What is energy at A? So that's only because of the spring. So that's K over 2 x naught square. Work done by the friction is mu s times normal reaction. In fact, first is F dot D, and energy at B is only because of the kinetic, right? Because the height is not changing, so there is no change in the gravitational potential, and the spring comes back to its natural length when the block is at B. So it's just half mv x square. K is 10 kilonewtons, or 10 times 10 raised to 3 over 2. X naught is the compression, which is 5.4 centimeters, so that's 0.054 whole square. F dot D is, since the angle between the frictional force and the displacement is 180, so F dot D means cos 180, which is minus 1. So that's minus of FD is half M, which is 0.417, and Vx square. So that's coming as 10 raised to 4. In fact, let me just grab my calculator and try to solve this. 0.054 whole square times 1, 2, 3, 4 uh, over 2, which is coming as 14.58. So 14.58 minus frictional forces mu s times normal reaction. And the normal reaction is nothing but the weight. So F sub n, and the distance is 1.2 meter, and that is equal to 0.2085 Vx square. All right. So 14.58 minus mu sub s, that is given as 0.5. Normal reaction is weight. Weight is mg. M is 0.417. G is 9.8. 1.2 is 1.2. And this is 0.2085 Vx square. All right. So what is this value comes out as? This is zero point 0.5 times 0.417 times 9.8 times 1.2, and 14.58 minus this value. So this value comes out as 12.13. This is equal to 0.2085 Vx square. So dividing both sides by 0.2085 and taking the square root of both the sides, this value comes out as 7.63, that is Vx. So the velocity at the time it gets launched is 7.63 meter per second. Thank you.